Hello, everyone. Thank you for joining us today. My name is Yasmina Greco. I am with O'Reilly Media, and I will be your host for today's webcast. We'd like to begin today's webcast by saying a very big thank you to Limelight Networks for sponsoring today's event and let you all know Limelight Networks is a global leader in digital content delivery, empowering customers to better engage with their digital audiences by enabling them to manage and deliver their stories on any device anywhere in the world. Limelight's award-winning Orchestrate platform includes an integrated suite of content delivery technology and services that helps organizations deliver exceptional multi-screen experiences, improve brand awareness, drive revenue, and enhance customer relationships, all while reducing costs. Joining us today are Jason Tebow and Steve Miller-Jones, and they're going to talk to you about how to speed up mobile delivery by squeezing out network latency. Jason is a reformed serial entrepreneur and college professor turned digital superhero. As a marketing strategist for Limelight Networks, he helps organizations capitalize on digital technologies to succeed in today's online world. Jason has launched numerous startups using growth hacking strategies. He's helped public companies pivot business models, and he speaks internationally about the impact of digital technologies on business. Steve Miller-Jones has worked in the streaming and content delivery networking industry since 2008 and has a strong software project management and web application programming background. As a principal architect for Limelight Networks, he enables Limelight to understand how its services perform from the outside in and from the inside out. Using real user measurement data alongside synthetic and system-wide monitoring services, he leads development of products that ensure consistent, high-quality content delivery worldwide. Prior to joining Limelight, he was COO of Global Mix, which won the Streaming Media Best CDN in Europe award in 2009. Folks, we're really excited to have Jason and Steve with us today to present this webcast for you all. All right, as we get the webcast started, I'd like to go over a little housekeeping to help you get the most out of today's event. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Jason and Steve. We find that our audience usually has a lot of good knowledge to share, so we encourage you to chat freely during the event. However, if you have questions for Jason and Steve, please preface them with a capital letter Q so we know that they're for them and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is LLNWDelivers, Limelight Networks Deliver. We'll also push that out to you in the group chat. Folks, if you have any trouble with the event today, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you should have any trouble with audio or stalled visuals, try refreshing your window. And remember, the best thing you can do for a good audio stream is close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast, and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Jason and Steve. Hello, gentlemen.
Thank you, Yasmina.
Thanks.
All right. So why don't we get kicked off here? Really, what I'm going to do is I'm going to spend about the next 5 minutes just kind of giving you an overview of where mobile is and what's changed about the way users are interacting with content today. And then Steve is going to take the bulk of the presentation. He's really going to dig into 4 best practices we have around improving performance for mobile. So ultimately, this seminar is really focused on discussing what impacts your ability to deliver a great mobile experience. That means that we're focusing on distributed architectures and storage considerations and tactics for responsiveness and data management, which means that covering this range of topics doesn't give us a whole lot of time to get to a deep technical workshop-style presentation or to go into detail. right? So what we hope that you gain from this seminar is a better understanding of the complexity of mobile delivery and the strategies and tactics that you can employ to address this. So when we think about this, it's a world that's totally gone mobile, and I'm going to explain that in just a second, but before we do, why don't we jump into a quick poll question and really sort of get your sense of what you guys are doing for mobile. Okay, so why don't we push the results here to you so you can see what everybody else is thinking. And as you can see here, a lot of you are building a combination of adaptive HTML and applications, which is something that we're seeing a lot in the market right now. But there's still, a small portion of you who aren't doing anything, and then some who are really still focused on adaptive HTML. And that's really, really interesting, something to keep in mind as Steve goes through his best practices. All right. So back to that statement that it's a world gone mobile. So just how much of a mobile world is it? Well, when you consider this graph here that I've got displayed, that according to the International Telecommunications Union, there were about 6.4 billion mobile phone subscriptions at the end of 2012. That translates to roughly 91% of penetration globally, which means that a lot of people, to say the least, are using mobile phones. But that's up from a mere 662 million subscriptions just a decade ago. So you can see that the growth of mobile is almost exponential. It's really getting fast. And so we're getting to a point where there probably is going to be more devices than there are people on the planet. But really, when you think about it, it's not just the devices and the subscriptions that are increasing. It's the actual usage that's increasing. So in this graph from the Pew Center, we can see that the continued growth of the mobile internet usage over the past few years has gone up significantly, which coincides exactly with what Google discovered in their multi-screen world study, that more and more people are using their mobile devices more and more every day. So it's not just a one-off, I'm going to look at a web page here and then never look at it again on my phone. I'm going to look at probably that web experience and that digital application across all of my devices throughout the day. Now, one of Google's key findings in their multi-screen world study is that digital is supplanting the traditional ways that we consume media. So we are becoming a digitally focused world, and when it comes to our leisure time, we are spending a lot of it connected. Unfortunately, though, as this graph from Strange Loop really shows, consumer expectations haven't changed at all. They totally remain the same. They want the same kind of performance from mobile digital experiences as they do from their desktop. And this is kind of encapsulated in this fantastic quote from Forrester. So what does this really mean to you? You're sitting on this webinar, you're thinking, all right, I got it. You've just beat me over the head with a sledgehammer. It's a mobile world. Everybody's using mobile devices. What does this really mean? Ultimately, there's an impact of mobile on digital experiences and the way people engage with them. And that's something that we need to keep sort of really in front of us as developers and as organizations, that it's no longer separated in between PCs and TVs and mobile devices. It's now just one consistent digital experience, and consumer expectations remain the same across them all. So now I'm going to hand it over to Steve, who's going to talk a little bit about the impact of mobile on your actual applications.
Great. Thanks, JT. Good afternoon, good morning, everybody. Thanks for joining us. So that was a great intro to what the expectations are and what's happening in the mobile world. And I think, one sentence from me before I move on this, I think what's really important and what I'm going to try and focus on as we get to what some best practice ideas are, is that we have to design for mobile specifically. Even if our digital presences have to be across all these devices in a unified way, we have to design for mobile specifically because they have certain limitations and pressures that the devices and the networks impose upon us, that some of which we're in control of and we can control, some of which we're just not in control of. And if we don't regard them well, then we're going to end up with poor mobile experience for end users, which is going to be a negative impact on our digital experience. And I think there's no doubt about that. So the impact of mobile on performance, and if we break performance down into sort of two areas, speed, of course, the speed of delivering things, and performance, I think the impact of mobile is considerable. We've got to think about connection times, times to first byte, times to download total objects, and the throughput that we're able to achieve from our application infrastructures when we're delivering apps, websites, content to mobiles. And we have to think about how latency is impacting our speed. The architecture of our IP networks is really based on a best effort delivery model, and it makes no guarantees at all about end-to-end performance. And what we'll see is that in mobile networks, the latency is highly variable. So we're going to talk a bit about this. So let's define what I think the 5 key areas of latency really are, and break them down into ones that we can and can't affect ourselves. So most importantly, we have what's called a propagation delay. This is the delay it takes and the time it takes to transfer a piece of content from one place to another. This is basically impacted by the speed of light and the distance that we have between 2 points. Secondly, we've got serialization of data, which is the speed at which we can get data off a disk and write it into the bit stream to get delivered across our networks. We have protocols and protocol negotiation which impact latency. So, we know we have HTTP three-way handshakes, and we know if we use HTTPS that we have additional round-trip overheads with security negotiation. So the protocols we choose to use in our applications have additional latency overheads that are being introduced. And then we have routing and switching, or routing and switching, along the way from our origin infrastructures towards the mobile networks, some of which we'll be in control of and some of which we're not. And then the queuing and the buffering, or any congestion that takes place within those networks, which are probably completely outside of our control as application developers. If we are the mobile network ourselves, then we're probably more in control of it. If we're an ISP, we have some control of these things. Content delivery service or content delivery network has some control as well. So there's definitely these areas of latency which are going to impact us in the mobile world. We have control over some of them, and we don't have control over others. And that leads us to think about what performance is and how the latency issues that we have are going to be addressed. So service availability and service latency, we're totally in control of. It's in our infrastructure. Right? If our infrastructure is available, it's available. If our service is taking a long time to do queries or to read from disk, then we're introducing latency before the mobile guys even start trying to get to our content. And then we have things like the reach of the networks that our users are in. That's impacting on performance. The capacities the devices have, how available is the content when the devices are trying to get it, the caching available in the devices, the kind of application areas that we can create in applications or in mobile HTML. If, for example, I move 2 feet in my house and I lose my signal, is the application going to error or not? And then thinking then about the content location, where is content placed? These are all elements of performance that we really need to consider carefully when we're talking about performance, and latency is key to it. So I'm going to push another poll towards you, and this is a question about latency. So the question is this: what do you think the inherent latency is within a 4G mobile network, within the network, in between the towers and the gateway towards the internet? Do we think in a 4G network this is 40 to 50 milliseconds, 150 to 200, or 600 to 750 milliseconds? So I'll leave this up for a few more seconds, and let's push some results in 3, 2, 1. Okay, so most of you think that in a 4G network, the inherent latency of the core network between the towers and the packet gateways are somewhere in the 150 to 200 milliseconds range. What I think is interesting, let's have a look at some data that we have, which very generously has been presented in Ilya Grigoryk's recent book, the High Performance Browser Networking book. It's from AT&T, and they determined that the expected latency in the core network in the carriers for 4G is about 40 to 50 milliseconds. But then we see what the difference is as we go down the 3G generations and the 2.5G generations. And so primary complaints about designing for the mobile web, right? The primary complaint is its high latency. So to dig into this a bit more, let's look at a single request and response process and see if we can see if the latency is predictable in any parts of it, and then perhaps as application and website developers, we can choose where to focus our attention on in order to deal with latencies that are being introduced. So here's a latencies during request process sort of analysis. Let's assume our user is connected to a 4G network. Their device is in an idle radio resource controller state, so it's not connected to the tower. The user types the URL and hits go. What's going to happen? So the first thing that happens is the radio has to synchronize with the radio tower, get a radio context and resource assignment, and this takes several round-trip times to the towers. In older generations, this is even slower than in 4G. So in 4G, this is about 100 milliseconds. This is the sort of control plane latency of waking up the aerial from an idle state, getting it working, getting it resources allocated from the tower. And now we can start transmitting data at the agreed rate and power that has been agreed with the tower. So the first packet takes a long time because of this change in the RRC state transition. And then the packets after this, at the sort of user plane, only really incur one hop of latency to the tower. So this is probably about 5 milliseconds or so, as long as the radio stays in a high power state. So if the radio changes state and you still need to use it and you need to do more, you're going to incur more latency again. So this is a key piece of the performance puzzle in mobiles, is dealing with the radio and making sure it's used in a way which is performance orientated. Then we have packets that have to travel through the core network, and this is going to be variable for each of the individual mobile carriers and probably the city you're in and the cell network that you're in at that time. And then finally, the packets have to go out onto the public internet and get routed towards your origin, your infrastructure, by the mobile carrier's packet gateway. So then let's look at the response path. What happens in the response path? Well, first of all, perhaps obviously, the application environment has to send a response back. It has to receive the request, determine what the response is going to be, and then put it onto the wire and send it back. So we have some variable latency between the application environment and the wide open internet towards the mobile network. And then we get into the core network of the carriers, and we're basically made up of four pieces. A packet gateway, which is this is the public gateway that connects the mobile carrier to the internet, and it's the termination point for all the external connections. And it also allocates and maintains IP addresses for the devices connected to the carrier. Associated with this is the policy and charging rules function, which deals with things like policy enforcement, rules for billing, quality of service filtering, DOS protection. It's a logical function. Unfortunately for us, the packet gateway has no real idea of where the users and the devices are, nor what the tracking areas within the network are. So it has to talk with another part, the serving gateway, in the network. And so the packets get routed to the serving gateway, but unfortunately for us, the serving gateway may also not know where the user is either. And so there's the fourth piece of the core network typically, which is called a mobility management entity, and this is queried by the serving gateway for the location of the user so that the gateway can connect to the tower serving the target device and route the data to the user. So this is pretty complicated. It varies a little bit from network to network, of course. And although the user plane latencies are pretty low, there's a variability in the core network that we're not in control of at all. We don't know how long it's going to be. So we can deliver and we can optimize the delivery of our content towards the core network, and we're then at its mercy as it then passes packets on towards the end users. So I'm just going to hand back to JT to go over why there's a lot of there's a lot of complexity outside of our control, and it's vital that we learn to work with this paradigm to deliver our amazing experiences.
Thank you very much, Steve. And that's a lot of interesting information that you're providing there. So it's really important that we start thinking about mobile first. And the question then becomes is why? Why do I really need to think mobile first, and why do I need to have this consideration in front of me? Well, in short, there is some measurable impact of performance on the business. And it's clear from the statistics that we've assembled here that, that goes without saying, right? We know that if we have poor performance, our business is going to suffer because we're not going to be able to convert users. They're going to abandon sites. And again, with more and more people using mobile devices and being on the go when they're accessing this, it brings to the forefront the need to design and architect and develop for mobile first. All right, so I think we've hit you over the head enough with about mobile, with why it's important. Now let's get on to the best practices. All right, and here's what we're going to talk about today. All right, this is what Steve's going to go over here in just a minute. We're going to talk about distributed delivery. So how does that improve mobile? And again, all of these are mobile best practices. So it's how does this improve the mobile experience? So storing objects closer to end users, decreasing wait time and improving responsiveness, and keeping data in flight during downloads. Now, Steve's going to address each of these in their own, and when he's done, we'll return back and we'll talk a little bit more about what this means to you as a developer and as an architect in building out your digital experiences. So, all right, Steve, I'll hand it back over to you.
All right, great. Thanks, JT. So, as we've seen in the previous slides, we've got to get data to and from the mobile carrier core networks, right? At which point we lose control of the delivery to the device to an extent. And our applications and websites have to negotiate the delivery of the content into and requests for it into this core network efficiently and effectively. So let's have a look at what we can do and talk about what we can do as application developers and delivery service providers to reduce the latency in the public internet and in our own infrastructures. So I think the first thing to say is, be everywhere. And I think this is a key piece to take away about how we should distribute content. We've got to try and get the content to travel the shortest distance to the end user to minimize the latencies inherent in every hop and inherent in the propagation delay, and that may be in congested networks or highly latent mobile networks. And then we also got to think that users move between networks while they're using their mobiles. They experience variable network speeds. Again, if I move to my kitchen, I'm going to drop 2 bars of signal. And then they're going to change locations within a single network point as well. They're going to walk down the street or whatever. So they're never, or probably not ever guaranteed a maximum throughput that's offered by the radio interface. And so our applications have to be able to adapt to the changing conditions of the wireless channel carrier, the wireless channels, the carrier networks, and the public internet. So I think what we can think about and how to address some of these concerns is think about designing infrastructure to support applications and users, and think about how you can best place content close to the users. So there are a number of models that are used if you want to build your own distributed infrastructure. So there's an idea that you could build something that I'd call a sparsely distributed architecture. You could distribute a small number of servers into a wide variety of networks and use some form of connecting them together across the public internet. You could also probably build a more densely structured collection of servers, so in individual data centers grouped close to the end user networks where you're trying to deliver your content to, and again connect these together without any kind of network. And you could probably build yourself a more dense points of presence that are all connected together with private networks that would then give you much more complete control over how to get content out towards the edges of the network and into the carrier networks. And I think these are also a number of different models used by different service providers and different CDNs, such as Limelight or Edgecast, Amazon or Akamai. And I think it's worth understanding how they're different from each other, why they're different from each other, and what kind of benefits you're going to get from the different types. And I suppose a quick question is, what difference does it make? Does it actually really make a difference how I architect these things? If I just put it close to the end networks, or if I just connect to the networks, it doesn't matter how it's distributed and how it's architected. And I think the answer is yes, and let's try and go through why. So what are we trying to solve for what we're trying to solve for is the fact that the internet is generally a series of unoptimized networks that are owned and controlled by different operators. But what we're trying to do as application builders for mobile users or website builders for mobile users is reduce the latency in the delivery of our dynamic and our static content. But yet we have this black box, which is the internet, in between our content origin servers, which are in a data center somewhere, and the mobile networks, which have users with lots of different devices all over the place. And it makes it really hard to control the quality of content delivery when it's like that. So one way of addressing this is to think about the static content delivery and delivering static content. And this is what typically CDNs do. They're offering you a way to keep content that does not change much close to the end users by using caching technologies and the variety of distribution architectures that the different CDNs use. You could build this yourself by locating equipment strategically and communicating back to your end infrastructure over the public internet if you wanted to. And this is a pretty typical sound model for static content caching and delivery. Building it yourself means you stay in control, but you have to carry CapEx and OpEx required to build, manage, and maintain that level of distribution, that level of architecture. And CDNs can provide this for you in their various forms, meaning that you will lose some control of delivery, but you'll reduce your CapEx and OpEx constraints considerably. You'll be able to maintain your focus on your own infrastructure and maintain your core competence in building the applications and websites that deliver what's differentiating out your company to your end users. But then I think this gives us a significant issue that we have to think about. We need to think about how we symmetrically accelerate content across the internet from the origin servers. And this significant issue is that a lot of our applications on our phones and our mobile devices are made up of application experiences with dynamic content in them, which is typically uncacheable. So even though we're using all this static content caching and delivery, we still have to traverse the public internet to get to the data center. And this is where we can start looking at service providers who offer dynamic site acceleration or dynamic content acceleration services. But I think it's important to consider that you choose a provider who actually accelerates all parts of the content journey. So you need the static caching, you need the static content caching and optimizations for content delivery in the last mile between the CDN edges or the distribution edges and the mobile carriers and their networks, their core networks. And you also need to optimize the retrieval of dynamic content across the public internet towards your origin. And then finally, there's the connectivity that you have at your origin, your leased line that you have to your ISP, that first mile of connectivity between the origin and the public internet, which needs optimizing too. So if we think back to the other delivery models that we were looking at earlier, it's clear that service providers who use the internet to connect their nodes together may be able to offer some of these things, but only those who are really offering and are operating a privately controlled and managed network can optimize for all three of these miles. The first mile between the origin and the provider, the middle mile from the origin-facing edge, and from there to the edge, user-facing edge, and then in the last mile to the end user. So I think it's important to think about what you need for your applications, what kind of data you're transferring, how much is static, how much is dynamic, what kind of distribution architecture should you use, what kind of optimizations do you need for your application to work, and then go and look at other service providers and look at the CDNs, including Edgecast, including Akamai, Amazon, Limelight, and look at how they offer different content acceleration services. When you're selecting one, consider the different architectures, ask about how they work and why they're good for you, consider the connectivity and caching capabilities that they have, and think about what differentiated benefits you need for your applications and for your end users and for your specific needs. This is some recent data gathered by Sodexis, which shows the relative performance of 4 dynamic content delivery services. The y-axis shows the time taken to deliver dynamic content from a Sodexis origin, and a lower score is better. So use third-party tools that show you how the different service providers perform against each other when you're making decisions about who to use. So we've talked about distribution strategies and architectures. I hope that's given you some ideas for how you could build your own distributed architecture, and the kind of questions that I think you should ask when you're looking for distribution services from CDNs if you're not going to try and build your own distributed architecture. So now we're going to talk about storage a little bit and talk about how we think it's useful to have content closer to the end user when it's in storage. And so we're going to start with a polling question about storage, and we're interested to find out what kind of storage you guys use. So push the question at you. What kind of storage are you using for your content delivery? Dedicated, cloud storage, or a combination of both? So let's just leave it a couple more seconds. And then I will push the results out, I think. Okay. And so we can see quite a lot of you, nearly half of you, are using a combination of both dedicated and cloud storage, which is a trend we're seeing. It was interesting at a Velocity conference recently. Dropbox gave a talk where they discussed how they ended up using cloud storage for parts of their infrastructure and dedicated storage for others, because they offered different benefits depending on what type of data they had. So they had their metabases and they had their objects they were storing, which was people's files, of course. And so it's interesting that there's a combination of both things, and I'm sure all of you who are doing that have good reasons to choose cloud for certain pieces and dedicated for others. So what we're going to try and do now is talk a little bit about the fact that we are in control of our content and where we place our content relative to the networks, even if we're not quite in control of what's happening inside the mobile networks, the mobile carriers. And we need to think back again to the questions about latency. Excuse me. The definitions about latency. We have the data serialization as part of latency. Getting data off disk and getting it onto the wire and getting it into the bit stream is a key part of latency, right? And then the propagation, the distance between when you get it onto the wire and how far it has to go and how long that takes, that speed of light calculation piece of latency. Those are two key items. So if your content's far away from your end users on slow disks, then you're adding latency into the delivery of your content to your mobile users before they've even really started requesting it. So what I'm going to try and do now is give you just a very quick demonstration in a browser window of some of the Limelight Cloud Storage product, and one of its features, one of its unique features, which is what we call policy replication. In our cloud storage product, we distribute it widely throughout our entire network in every point of presence we have, and we use policies to determine for each piece of content where it should reside and how many copies of it should exist throughout the network. This enables us to do things like place a piece of content both in Korea, for example, Germany, and New York, knowing that that content is then close to the edge and can be delivered with the lowest cache miss latency possible when users in those areas are trying to get access to that content, and the cache miss requests don't have to travel across to, say, East Coast or West Coast US into another cloud service provider's storage, for example. So let me try and get my screen shared, and I'll show you how this works. Okay. And I've got a spinning wheel. As usual, in every demonstration I've ever done, it doesn't quite work as you expect it to. Okay, here we go. That's coming up. If you'll just bear with me a second. Okay, I think I can make it go green. You should be seeing my screen, and I've got the Limelight Cloud Storage browser in this. So what I'm going to do, I'm just going to use the interface, and I'm going to pick a picture. It must be true. It's on the internet, according to Kermit, apparently. I'm just going to upload this. So while it's uploading, I'm going to look at another object we have here and look at the get file info. And this is going to load a map. And it'll tell us for the file path we have, a policy name in the middle, and then copies complete. How many copies of this object are there and have they been completed? So we can see this is a 3-copy policy we've got, even though it's named slightly differently. And it's in 3 places and 3 RPOPs in the USA. If we look at the object that I just uploaded, we can also then see the get the file info, that this is in a queue and it's going to be added to the POPs in due course. This information is also available via an API, so you can use an API to create callbacks and so on, which will tell you after you've uploaded content when it gets into all of the places as described by a policy. And what we can see here is a policy map. This shows you a policy called All Data Centers. This shows you where, if you chose to store your content in every POP in Limelight's network, where all of those POPs would be. So I hope that's of some interest. Let's see how our queue is doing for this new file that we just uploaded. There we are. So it's getting into one of 3 locations. And I was hoping it would have been in all 3 of them. So as I said, with every great presentation, all the rehearsal in the world doesn't prepare you for the point when it doesn't quite do what it's going to tell you it's going to do. I'll try and come back to this later on to show you that this did actually get put into all 3 locations as we were expecting. So let's pop back to the slides. And let's turn that off. Okay, so I think what we're really trying to point out, if I can get this slide up, is that, latency does matter. And I hope the demonstration shows you in some way that there are definitely options available that will enable you to store your content in more than one cloud or dedicated storage location, and that this will help you keep content stored closer to end users. Think about using storage in East Coast USA and trying to get it on cache miss to a user in Germany. It would probably be faster, it should definitely be faster, if the content's actually stored in Germany close to the edge for the cache miss to be filled from there. Being strategic with your choices should enable you to store your content close to the end users for low propagation times and reducing the latency on cache fill. And if you're looking at any kind of storage situation yourself or any storage services yourself or dedicated storage, high-performing disks are going to, like SSDs for example, are going to ensure you have low serialization times on cache fill requests too. There are obviously other services like Amazon or Rackspace who are available to help you implement a solution that you need when you're closing cloud storage. But remember that the goal should be to store the content close to where your end users are and to reduce the latency in delivering those cache miss, that long tail library cache miss, to the end users. So let's move on and talk about time to wait. Mobile users experience the same responsiveness from mobile websites and apps as they do from desktop websites, or at least that's what we're told they want to do. As we all know, hope is not a strategy nor a tactic, so we need to be smart about how we cater for mobile users when we design the websites and applications, not just hope that it's going to work well because we've built a pretty looking app. So the first thing I want to say is about adaptive websites. And I think the key point to make about adaptive websites is to code for mobile first. Thinking about what we have to do in the mobile phones, thinking back to the request and response process, we have to wake up, potentially we have to wake up the radio, and this is an expensive thing to do. So we're going to waste some hundreds of milliseconds communicating before we even get any data. So what we want to do as a mobile user is make sure that the first iteration of the HTML we get and the objects we get, the images, the JavaScript, the CSS, that are going to be queued up in the browser queue and executed as gets. We want that first set of data to be suitable and appropriate for the mobile and needed for the mobile. Okay? We don't want to waste the round-trip times that we have to sacrifice to get the user connected to us by giving them the desktop CSS first and the browser and the mobile browser 1 second. We've got to let them keep and use what they get first so that the experience is optimized for the end users. We should need to make the desktops with their hard wires, their Wi-Fi, their superior cache and capacities do more work and throw away the content they don't need. They're much more capable of doing it. Users are prepared to wait slightly longer for them to do it than they are on the mobile. So we need to make sure we're coding for mobiles first when we're doing our adaptive websites. And then I think we have to think about improving responsiveness. Time to action is more important than time to paint for mobile users because they want to interact with the page. They don't want to watch it painting, they want to interact with it. And mobiles are different from the other browsers that we have and our desktops and our laptops because of things like their cache, the radio or antenna, and the batteries. So let's spend a moment and talk about images. And I think this is a pretty complex topic. You could probably spend an entire hour talking about how to deal with responsive images on mobile phones. But let me just spend a few minutes talking about it and give you what I think are 4 main solutions, best practices for dealing with images on mobiles. So if you think about a mobile browser, let's talk about Chrome. I think you have about 32 meg of cache in a Chrome browser. If you have more images than that, for example, then you're going to start burning that cache, burning the memory, using the radio and battery more than you need to. We also have to think about how devices and mobiles require resolution changes or cropping to get the images delivered efficiently to them. So we don't want to deliver the wrong images and then have to go and get additional ones. So I think there are 4 solutions for really thinking about solving image issues. The first one's fairly obvious. You should use the best lossless formats you can. Look at WebP, for example, the more modern lossless formats. Look at what browsers will support them. If you're building for apps, look at what devices will support them, and try and use the high quality lossless formats that are going to give you the lowest footprint and the biggest bang for your buck. I think that's the most obvious thing to say. The next 3 are also best practices I think we should be following. Think about art direction. So on a website you have some large images. Think about cropping single images differently for the mobile devices that have different resolutions and different screen sizes and can take different parts of your images. It may be easier for you to manage your image libraries that way, and the mobile is only going to be getting and displaying a part of the image. Send the right image to the right device the first time. So for Retina devices, for example, send Retina images the first time. Use cookies, use headers, use client hints to determine from your infrastructure which image should be delivered. Talk to your CDNs about doing request header analysis or resizing on the fly to make sure that you get the right object delivered the first time it's requested. In application experiences, I think we should be thinking about preloading. You've built an application experience environment. You know what's going to happen in the application. You know what the user is expected to do. And the images probably don't change. The images are probably highly cacheable. So think ahead, get them before the user is going to need them, and pre-think about what the user is actually going to do. So I think those are 4 things you could think about that are best practices when considering images in mobiles. And I think this is a hard topic. You can code for it in a number of different ways. There are 4 or 5 different approaches you can take with JavaScript to do progressive downloading, for example, or to determine what kind of device you have and which image you need. Talk to your CDNs about doing the request header analysis, looking at what type of browser it is that's coming through and serving the right image for that browser. Research your options and the image formats that are available to you. There's a small amount of cache available in the mobile browsers. I don't think we should expect users to have our objects in cache if they're using your adaptive websites. I think you should expect that they won't have them in cache. So what we need to think about then is the radio and the battery, and we need to think about conserving battery power. Because keeping the radio active is so expensive in terms of battery life, we have to try and maximize the amount of data transferred while the radio is actually on and minimize the number of additional data transfers that we're going to do. It sounds like I'm trying to say don't use the radio, but of course we have to use the radio. And I suppose the point to make is, and we'll talk about this more in a second, is if you have to wake up the radio, use it wisely. Every feature in the mobile has been designed to make the most use of the battery. And if you ever wondered why a feature in a mobile is the way it is, it's highly likely that the decision is down primarily to battery conservation. The two things that use the most battery in your mobile are the screen and the radio. So if you ignore these constraints and if you don't think about the physical delivery layers of the mobile networks and the challenges they're imposing, then it's going to lead to a poor, highly latent experience in the device and the application, and poor networking decisions and poor decisions about when to use the radio are going to have large negative impacts on the battery life and therefore on your end user's experience. I think we have to plan for connectivity. Applications have got to be robust in the face of networks conditions changing. I'm not expecting my application to stop working just because I walked through a black spot for a minute. But we can't assume that our users are connected, that they stay connected once they are connected. We need to think about how to eliminate unnecessary application keeper lives. We need to anticipate network latency overhead, which we can know about. And we need to account for state transitions in the radio if we're expecting to use real-time data. So I think there are some best practices to follow, which I'm going to go through now. I think polling is exceptionally expensive, and I think it should be minimized. And I actually think it's probably better to try and replace it where you can with push notifications and group push notifications together to send data to the devices. Aggregating and putting coalescing inbound and outbound requests together for efficiency may be an approach as well. I know that Google offer a push service for Android and for Chrome devices. I don't think it works on others, but look at using that. Think about how to use push rather than polling. If you need to use polling, think about why, and then defer non-critical requests until the radio is actually already active rather than you having to wake it up. If you're developing apps, work out how to monitor the state of the radio and the RRC state, because there's no doubt it's going to be used by other background apps or other apps that the user is using, and there may well be a time when you can piggyback and use it when it's already active to send your non-critical requests for data out. Thinking about state transitions and real-time updates, consider what's the best interval for real-time updates, and does it match the user expectations? So think about how your user is going to use your app or your website and at what point they're going to need the data and plan for it. Trying to use an adaptive strategy for updates based on usage, based on what the user is doing, network coverage, the radio state. Can you be adaptive in your application about when you receive real-time updates? And again, think about deferring inbound or outbound requests and group them together and do them all at once. I think it's important to be totally strategic about data use. So bursting and returning to idle, getting lots of small bits and pieces in one go, prefetching application data that you know people are going to use, prefetching third-party data like adverts that you know they're going to use. You don't need to get them when they need them. You can get them before they need them. And then you can maintain an application experience that's great for the user, that's minimizing the impact on the device and on the latency in the network. Decoupling the user interactions from the network communications is going to do this well for you. So that brings us to this final area we're going to look at, which is keeping packets in flight. And the first thing to say is size really does matter, because different sized objects need different kinds of help. So I think your options for optimizing highly latent networks are really centered around two things: WAN acceleration, TCP stack optimization. So, there are two statements on the screen there about TCP optimization. It's really easy to say size your windows and reduce round trip times, easy to say, and research protocol maximization options, also easy to say. So what do I really mean about that? I think you've got to be focused on the efficiency of delivering the packets of data your application needs. There might be small objects, there might be large objects, and they have different needs, right? So I think my recommendations of best practices of things to think about when you're dealing with TCP optimization are as follows. Firstly, install the modern versions of your kernel in your infrastructure. Get modern versions so you can take advantage of the optimizations that they present you. And the things that you should be looking at are increasing your TCP initial congestion window. There are recommendations out there in the wild about what value you should start at. The benefit of doing this, if you don't know, is that it transfers more data in your first round trip and enables you to accelerate the growth of your TCP window. And this is critical for bursty short-lived communications, which is what we're advocating when we talk about bursts of small data put together into the mobiles in fewer round trip times. The mobile radio interfaces are optimized for bursty transfers, and grouping stuff together as much as possible and delivering it as quickly as possible is going to help you. Disabling slow start after idle is something you can look at for improving the performance of long-lived TCP connections, such as the connection between the packet gateway and the edge of your infrastructure, for example, or the edge of a CDN in your infrastructure. And then you can transfer data in bursts over a TCP connection which is staying open for longer. Enable window scaling, and this allows high latency networks to achieve a better level of throughput, and this is the kind of thing that can help you if you're looking at large objects and you're trying to maintain a constant stream of data during a download. And finally, a fourth one I think is important to think about is TCP fast open. This is newer than the others. It needs client and server support, so you need to check that your application is going to support it, or your dynamic website, your adaptive website, and the devices you're targeting it's going to work on. But it essentially allows application data to be sent in the initial SYN packet in certain situations, which essentially reduces the number of round trips that you're going to need to take. And I think if you want to look at implementing these things completely throughout the end-to-end communication to the mobile device, you've got really two choices. You can manage it all yourself, or optimize all of your infrastructure with WAN acceleration technologies and TCP optimization strategies. And some companies are very efficient and very effective at doing this themselves. It is complex. It requires your own dedicated resources and knowledge to implement and support for your operation. But the key benefit of you doing it is in your complete control. The other option you've got, of course, is to utilize a service provider which offers you combinations of middle mile optimizations, WAN optimizations to origin, TCP optimizations to origin, and optimizations in the last mile to the mobile networks as well. The benefit of this, you get to market faster with your optimizations. It's a CapEx, OpEx question, essentially, and it's also about your core competence. And then the con of this, really, I suppose, is that you have to give up some control of your delivery, but you still maintain complete control over your origin infrastructure and the optimizations you put in place there, and you can expect any service provider you use to just obey what your origin is asking it to do. And if they won't, I think that would be part of your decision-making process about which one to use. So I think we're going to sort of go into some parting thoughts. I hope this has been interesting for you, and I think I'm going to hand back to JT for the final summary.
Thank you very much, Steve. And that's exactly it, right? Let's just do a quick parting thought in summary slide, and we'll leave this up here as we go through some Q&A as well. But really what Steve covered was those 4 best practices, right? When thinking about how you're going to deliver to mobile, it's about distributing delivery, about where you're storing those objects closer to end users, right? It's about decreasing time to wait and improving responsiveness, and then, of course, keeping data in flight during download. So it's clear that mobile has some complexities. These are things that we need to consider or keep in consideration as we're developing our digital experiences so that we design for mobile first, right? And that's clearly what we're trying to get across, is that mobile, because so many users are moving in that direction, really requires us to think of it first and not last. And if you look at some of these other summary points, really that service providers can help you address a lot of these challenges and really sort of remaining focused on the digital experience, differentiating your service for your users, right? It's really sort of critical. Now let's look at some Q&A. We've got a bunch of great questions. We don't have a whole lot of time left, but what I'm going to do is I'm going to look through the questions. I'm just going to ask a question. I'll either answer it or I'll hand it off to Steve to answer. So why don't we get started with that? The first question came in was somebody had a question about the source for delivery ensures engagement slide. That's where we have 5 or 6 data points on there about the impact of performance on digital delivery. And I'm just going to go through these top to bottom. And I know I don't have the slide up right now. What I'll do actually here is I'll run back up the list and I'll put that slide up. So this is the slide that was in question. So this first point comes from Marissa Mayer. She gave it a Web 2.0 conference. So obviously that comes from Yahoo. The second one comes from Amazon. That's something that we found on the Strange Loops website. So Strange Loop is an acceleration provider. The third one is from Tagman, the tag management company, and that's in conjunction with the study that they ran with one of their customers that's also supported by an Aberdeen study. The fourth one comes from Kissmetrics, and the last one comes from TubeMogul. All right, so let's move on to the next question. I'm going to jump back to that summary slide just to keep that up. This one's for Steve. The question was, can you make a statement about bandwidth and latency?
Sure. So the latency the you experience and the bandwidth may not necessarily be totally combined. I mean, the distance from San Francisco to New York is the distance from San Francisco to New York, regardless of how much bandwidth you have, and the rate at which you can pass data along it. So when you think about latency, we have to think about how far data has to travel, and then we have to think about how fast we can push it through. So they are interlinked, but they're also, it's round trip times by numbers of round trips, and then how fast you can push data out doesn't necessarily mean you can move it faster than the speed of light.
Okay, oh, that's great. Looks like we've got another one for you as well, which the question is can you expand on how your cloud storage benefits me when the CDN should be caching my content anyway?
Sure. So CDNs do cache content, and that's one of their primary purposes. But if you have a long-tail image library or a long-tail document library or video library, you may not have everything in cache everywhere. And certainly the first time something gets requested, it's not going to be in cache. So there are definitely times when the CDN is going to receive a request for something which is going to be a cache miss, and the edge of the CDN will have to go and retrieve it from the origin. So if the request is in Germany, for example, they made a request to their local CDN edge. The CDN edge is a cache miss, and it has to go all the way to somewhere in New York or Virginia to get the content. That's an Atlantic round trip time that you've got there. If the content was residing actually close or next to, even in the same data center or same rack as the edge server, for example, then the round trip time to get the cache miss, to get that content into cache and deliver it to the end user is much, much lower. And this is really the benefit of using the distributed cloud storage architecture.
Oh, fantastic. We got another question here about the cost of CDN, and the question was, do you have examples? And I'll answer that. It's really tough to give costs for CDN over the phone, obviously, without understanding more about the business requirements of delivery. So there are lots of factors that can influence how much a CDN will cost. CDN can be very, very cheap when there's not a whole lot of assets to deliver, so there's not a lot of bytes to deliver, and the regions are very limited. So maybe you're delivering to North America in a very small pocket, and you've got a very light website. That's going to be a very different cost than, say, a Netflix would have for delivering all of their videos around the world. So it's really hard to give examples of that, over a webinar. My best suggestion would be to just reach out to the CDNs you're interested in and describe your business and how you're going to be delivering your content, and they'll get you some pricing examples. All right, another question here. This is a really great question, Steve. This is for you. It says, wouldn't treating the mobile device as the edge of the network and caching there provide even lower latency? Can any of the CDNs do that today?
That's a really interesting question. So there are additional caches on the device that certainly apps can use. I think it's possible to access them in some browsers, and there's obviously some storage on the device. I think it's a complex thing to do to keep track of where the objects are. Obviously, not everyone's mobile's on all the time. You may drop in and out of signal. You may go through a tunnel on a train while someone's trying to download objects for you from your device if you're using it as a storage object, for example, in some kind of wide distributed grid architecture or something. I think it's a possibility, and it could provide some kind of low latency, but thinking back to the aerial, what state is your device in most of the time? Most of the mobile phone manufacturers are trying to make your phone not do anything most of the time to conserve battery life. you using the screen as the single most highest drain of power, followed by the antenna. So if it has to be in a hot, active state all the time, you're going to drain your battery in a number of hours. So if your mobile device is acting as a storage device of some kind for other people, and it needs to be on all the time, you're going to experience, at the moment, with current battery technologies at least, a significantly poor battery life on your device if it has to be in a high activity radio state all the time. So I think there are a lot of challenges in doing that. I think it's really interesting to think about how you could do it in a closed environment maybe, or looking at how those kind of issues could be overcome. I don't think any of the CDNs are actively doing this now. I think some have storage technologies that are looking to determine how better to address mobiles in the long term. I don't think anyone's doing it right now. I could be wrong.
Oh, very interesting. And we've got one last question, and this one is right up your alley, Steve. It's, are there any third-party benchmarks to evaluate CDN performance? And I promise you, we did not type that one ourselves. That was actually asked by someone.
Okay. Yes, there are. I would recommend you go and look at some of the RUM vendors, real user measurement vendors, such as Sodexis, TurboBytes, Conviva, and look at their public data where they have them. And look at what they say about dynamic site acceleration, dynamic content delivery, as well as your static object delivery. But certainly Sodexis is a great one to go look at. And we had a slide up earlier which was taken from Sodexis about their benchmark for dynamic content acceleration.
Yeah, and that one compared the DSA offerings of some of the major CDN providers directly, correct?
Correct. So this is comparing major CDN service providers for their ability to deliver dynamic content specifically.
Fantastic. Well, that looks like that's all the questions that we have today. Now, of course, Steve and I are also available via email. Whenever you need to ask a question, you can reach me. It's jt@llnw.com, and you can reach Steve at smj@llnw.com. Again, if you have any questions, we're more than happy to answer them. But until then, we really want to say thank you for taking the time out of your day to listen to this webinar. And we hope that you got a lot out of it about not only the complexities of mobile delivery, but also how to improve that performance with our 4 best practices. And I will hand it back over to Yasmina to wrap it up.
Excellent webcast today, gentlemen. Thank you so much for sharing all your knowledge and expertise with us. Folks that attended our webcast today, we thank you for attending the webcast and hope you benefited from it. And I am pushing out, folks, an email address into the group chat right now. So if you didn't open that group chat, do open it. There's an email address in there to Limelight. A lot of you had additional questions regarding costs and so forth, so please use that. And we want to let you know, as you do leave the event, there is a green file folder widget in your widget tray. That widget has a lot of details and information in there for you, provided by Limelight. We've got a copy of the slides as well as lots of PDFs and white papers, so great information there that can really help you with your day-to-day, so please do check that out. Also, as we close out the program, we would like to say a very big thank you to Limelight Networks for sponsoring the webcast today. Folks, this will conclude the event. Goodbye, everybody.